Hi, Assalamualaikum. We are from Group 2. Today we are going to present our group project. But first of all, let me introduce myself. My name is Amir Akmal bin Jasmi with ticket number DF210015. So my others member, which include Hamdan bin Hamza, Nur Aisyah Fariha, Nur Ain Hanisah, and Akmal Arif. So let's begin. So as a Malaysian, we are familiar with flooding, right? Flooding is a challenge that Malaysian community suffers every year, in particular state, obviously, that causing property damage and loss. Poor damage system in home development appear to be the root cause of this problem. Of course, proper drainage systems are essential and important when building property because they are used to transport rainwater to pond, lakes, stream, and rivers. So, let's take the nearest example, such as drain at Taman University Palit Rajah. We discovered that if the rain is left untreated, it may create the bigger issue. So we are here to make that change by recommending the best channel section and discuss the drain issues. So here is our objectives of this project. First, to identify and justify the reason why flash flood occur at the location. Second, to provide the design of stormwater drainage system required to be used authority for drainage design in Malaysia. Third, to determine the best type and size for chosen drainage system along the proposed drain. That's all from me. Thank you.
My name is Nur Ain Hanisah binti Ahmad Syamuddin. I will present the methodology of this project. First, we go to the site to determine the condition of the drain, and then we measure the length, width, and the height. After gather the information that we need, we use the rational method to calculate the peak flow. Then, based on the peak flow that we get, we propose new design of the drain. So, the new design of the drain is to prevent the flood. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name Hamdan bin Hamza with metric number CF210321. So the next point I will explain about the result and also the analysis data. So the method we use to estimate peak of QP is a rational method. This is because this technique is commonly used in Malaysia and also other countries. So there are two equations contribute. For the first equation is the main equation, is to identify the peak flow, which is Q is equal to C times I times A divided by 360. So the Q is represented by the peak hour in unit meter cube per second, while the C is the runoff coefficient, A is the drainage area in hectare, while the I is the average rainfall intensity. So the I is the average rainfall intensity. The equation I is equal to delta times Tk divided by T plus theta. So T is represented by average occurrence. It depends on RE. While the D is storm duration in hour. In Masma state the D is between from 0.0833 to 72 months. While the delta Tk, theta and D is a fitting constant depends on rainbows location. The next point, I will explain about the general procedure to estimate the peak flow or QP. So the first step is to select design area in a drainage system. The second step is divide sub-catchment into a segment of homogeneous land use or surface slope. So next step is estimate the flow time or other flow components. The fourth step is calculate I for design area, while D is equal to time concentration. While next step is estimate the C runoff coefficient for each segment in Masma. The sixth step is calculate average runoff coefficient. While the last step is calculate flow rate Q for sub catchment. So we assume that RE is between 10 to 50 years, while the segment is a semi-urban location. So the formula contribute is Q is equal to C times I times A divided by 360. The next point, I will explain about the general procedure to estimate the peak flow or QP. So the first step is to select design area in a drainage system. The second step is divide sub-catchment into a segment of homogeneous land use or surface slope. So next step is estimate the flow time or other flow components. The fourth step is calculate I for design RE, while D is equal. The next slide, I will explain about the runoff coefficient of C value. So from the location project, we determine the location is category of a link and also parent house, that we assume that the C value is a residential area that refer to the major system. It must that the major system is more than 10 years RE. By refer to table 4.18, we got the C value is 0.90. The next slide, I will continue with the watershed area. So this area is in hectare unit. So we use Google Earth to conduct this watershed area. We just put the area catchment, which is Taman University Pait Raja. For the rational method, the maximum area is 200 acres. So from the Google Earth, we got the total area watershed is equal to 25.8 acres, is equal to 10.4 hectare. For this figure is about how we conduct the Google Earth. So for the first step, we have to put the area catchment. The second is the area, and it will automatic show the watershed area in this Google Earth. While the concentration of TD with equation TD equal to N times L divided by 6 times R power of 2/3 times S power of 1/2. The S is referred to slope, m per meter. So the function of time concentration is to get a value of intensity rainfall. So we choose the travel part of rainfall because the drainage is already built in that area. So the next point, I will explain about the Horton's roughness value. So the N value is a represent of Horton's roughness value. So from the MASMA, we assume that the land surface of the project site is average grass, so that the N value is about 0.045 from the table. Last but not least, I will explain about the frictional slope. So the equation that contribute of frictional slope is the higher value elevation deduct to the lowest value elevation and divide by the length of the channel. So we measured that the L is equal to 488 meter, and the frictional slope is equal to 0.0041.
Assalamualaikum warahmatullahi wabarakatuh. My name is Akmal Arif, and today I would like to explain about my part, which is the calculation part. As you can see from this slide, which is the existing channel around the Taman University Pait Raja, as we can see from these two pictures, this channel is in trapezoid shape. So we assume the measurement, which is for the top width, T value is 3.5 meter, Y value is 1.5 meter, and B value is 2.5 meter. So we proceed to the calculation for existing channel. For the equation 1, we have to calculate the area for the existing channel. So we use the trapezoid formula as we mentioned in chapter 1. After we obtain all the data, we get the output of 4.5 meter square for the area. For weighted perimeter, which is equation 1.1, also we use the trapezoid formula. the output is 5.66 meter for the vertical perimeter, and hydraulic radius, which is area over P, the output is 0.795 meter. And for the question 1.3, which is we have to calculate the drain flow or concentration time, the output, we obtain all this data from the MASMA and we put together to calculate, and the output is 6.69 minutes, alias 0.112 hours. So we proceed to the question 1.4. We have where we have to determine design flows for the drain. As we can see from this formula, which is IE average rainfall intensity, T average recurrence interval or ARI, and all the other formula. So for the T, we use 50-year ARI. D, we use 0.112 hours, and all of these data we obtain from table 1, which we find in MASMA. And after we got all this value, we have to calculate to find the value of average rainfall intensity, where we get 635.76 millimeter per hour. And then we proceed to calculate the Q peak, where this is the formula. C, runoff coefficient, A, drainage area in hectares, and I is average rainfall intensity. So after we get all of this value, we can calculate the Q peak, and the output is 19.71 meter cube per second for Q peak. After that, we have to calculate for the new design channel. Also the same, we use the same shape of the channel, which is trapezoid, but I extend the measurement for the top width is 5.5 meter, Y is 3.5 meter, and B value is 4 meter. So for the calculation is the same, and the formula still the same. For the equation 1, for the area, the output is 16.622 meter square, and for the vertical perimeter, we get 11.158 meter, hydraulic radius 1.49 meter, and after that, we can calculate the Q design for the new channel design, and we get the value of 28.81 meter cube per second. As for the analysis, the assumption of the discharge mismatch, which is to 28.81 meter cube per second. The design of the channel is to prevent any flood occur in the area. The design of the new channel section must have value discharge design bigger than value discharge peak. The design channel section is trapezoidal shape. The new design is changed in the Y height of the channel section, which is T top width and B bottom width. The assumption of discharge is met, which is 28.81 meter cube per second. Therefore, discharge for main equation that we get is 28.81 meter cube per second, while the discharge for rational method is 16.53 meter cube per second. Means that Q Manning is bigger than Q rational. And for the calculation, we have obtained the objective where we have to find the Q Manning value bigger than Q rational value. So that's all for me for the calculation part.
Assalamualaikum and hi, my name is Noor Arisha Fariha binti Kamaruzaman. My method number is DF210037. Now I will present the discussion of our project. Based on the location of this study, flash floods can occur during short and heavy rains because there is growth of grass and other vegetation in the drain. When it rains heavily, the ditch cannot contain a lot of water, which results in overflowing water and causing flash flood. The flow of water will clog and overflow onto the road. Next, the rate of soil penetration is also the causes of flooding in this location. This is due to the fact that the previous study indicate that the soil type in Parit Raja is thickly with little infiltration capability. So this analysis is done along with the new design to determine whether the current design is suitable for use or not. The new design made is the same as the current one, which is trapezoidal, but the head of the channel section, top width and bottom width are changed. The results show that the discharge of current channel design, which is 28.81 meter cubic per second, is less than the peak discharge of the new design, which is 19.71 meter cubic per second. The shape of the drainage basin also affects runoff. It is because the new design is bigger than the current design. When a design becomes bigger, it can accommodate more water that goes into the drain. Then, our project can be concluded that to prevent flash flow in part of Taman University Parit Raja area that occurs when it rains is by designing a new drainage with a larger discharge. This can be identified when doing the analysis that the current design is not suitable to withstand the excessive load capacity when the high intensity of rain occurs due to the small area. Therefore, if the drains are not cleaned properly, nearby buildings may become infected with harmful germs. So, the drainage system is one of the most important elements in a residential neighborhood. In order to keep the natural region safe and clean, drainage flow must be appropriately regulated. As a result, a good drainage system must be built to prevent this scenario from occurring and to limit the damage if it is unavoidable. That's all from us. Thank you.